In this lesson, we will be going through an introduction to permutation and combinations. Before we can tackle any questions involving permutations and combinations, we have to understand some of its important principles. The first principle we are looking at is the addition principle. As long as two or more events cannot occur at the same time, they are known as mutually exclusive events. In this case, we are going to apply the addition principle. Let's take a look at an example. I can take bus 65 or bus 128 home, or I can take the train home. In this case, if I'm taking bus 65 home, I will not be taking bus 128 or the train home. And similarly, the same can be applied for bus 128 and the train. Therefore, it is simply the summation of one way plus one way plus one way, which gives us a total of three ways. The next principle is the multiplication principle. It is a mixing and matching of events that occur one after the other. And these are typically known as independent and successive events. I can take street 1 or street 2 then after either road 3, road 4 or road 5 to get home. Now in this example, think of it as having two decisions to make at node 1 and at node 2. At node 1, we have a total of two decisions, which is either street 1 or street 2, which leads us to node 2, where we have road 3, road 4, and road 5. That leads us to the endpoint. Now from this diagram, you can see that these events are successive. So this is happening after the first event between node 1 and node 2. Independent events basically means that any decision between node 1 and node 2 does not affect events that are going on from node 2 to the endpoint, which, if you think about it, is true in a sense, because choosing street 1 and street 2 does not affect my decision in road 3, road 4 and road 5. Therefore, the total number of ways of getting home is simply the two ways between node 1 and node 2 multiplied with the three ways between node 2 and the endpoint. Alternatively, we can also understand this by the addition principle via a tree diagram. So at node 1, we have two options of street 1 and street 2, which leads us to our second decision at node 2, where we each have three decisions: road 3, road 4, road 5, and similarly road 3, road 4, and road 5. And that leads us all to the endpoint. Now, however, I'm going to label all these endpoints separately with a subscript: E1, E2, E3, E4, E5, E6, because the method to obtain the end is different. Now, if you were to see this, then these would occur as mutually exclusive events, because choosing street 1 and then road 3 is mutually exclusive from choosing street 1 then road 4, which is mutually exclusive from choosing street 1 and road 5, and so on and so forth. Hence, the total number of ways is the summation of all these ways, which still yields a total of 6. Now, why are these principles important? P&C is a logical thinking procedure. So if you are to do any P&C questions, you have to think of whether the event that you are considering is a mutually exclusive event or an independent and successive event, and apply the rule accordingly. So to recap, we have learned of the addition and multiplication principle. Similarly, we have learned how it may be applied throughout statistics, not just in P&C, also in probability and in distributions, which are in lessons to come. We'll continue on our principles of addition and multiplication as we go into the concept of combination. Combination involves choosing objects regardless of order, but with no replacement. Simply put, it is if we start with a certain set of objects, we want to see how many distinct groups can be formed from selecting a fixed number, say 4 objects from a group of 10 objects. And the last criteria to apply combination is that all objects must be distinct. The formula for combination is as such: n choose r, where n is the total number of objects and r is the number of objects to be selected. And this equals to n factorial over r factorial multiplied to n minus r factorial. Let us look at an example. Find the number of ways to select a 7-person group from a group of 10 people. This should be fairly straightforward, since people themselves should be distinct in nature. Therefore, we can apply combination, and as we have a total of 10 people, it would be 10 choose 7. And this will give us 10 factorial over 7 factorial, 10 minus 7 factorial, and that gives us 120 ways. Let's look at the next example. Find the number of ways to select a 3-person group from a group of 10 people. Again, if you apply the same concept, this would be 10 choose 3, and that gives us 10 factorial over 3 factorial and 10 minus 3 factorial. And this still gives us the same answer of 120 ways. Now, if you were to notice that these two answers are the same, it is because the denominator is the same. So let's recap. Combination is a selection without arrangement, as compared to permutation, which we will learn in the next lesson. And because combination does not factor in arrangement of the objects, it generally yields less number of ways than permutation.